here's our fourth prelab dealing with electronic configuration and dealing with fireworks. I like fireworks, and if you see enough fireworks, you notice that you see the same colors over and over again. And we're gonna do a flame test, and I want to see how well you guys do. And the truth of the matter is, sometimes people don't see. Just be honest when you see things. You don't have to deceive me. I mean, I tried it myself, and it's a lot of times really hard to see some of them. But just try this out and see how it goes. And lithium gives this hot pink kind of a color. And as we talked about in lecture, where this comes from are the energy levels. The energy levels are quantized, and as the electrons go up and down in energy, they release light, photons of light. So looking here, you can see the different colors and how they correspond to wavelengths. So really, red usually starts at 750 nanometers, looks more like brick red. Although most people can see it. Most people can see down to about 800. It looks really, really dark red. And then these different gradients here. So you can see that going through the different colors, you perceive them different. The different wavelengths you perceive as colors. Now electron configuration. So electrons, they have specific energy levels. So there are specific energy levels, and they're quantized, and they're discrete. Meaning, so between here and the 1s and the 2s, there's nothing between here. Electron goes from 1s up to 2s. And this y-axis here, x-axis is arbitrary. Y-axis means increased energy. It takes this much energy to go up. And how can an electron go up? Well, electrons go up in energy by a chemical reaction. So things reacting. Electron bombardment, so hitting it with electricity, kind of like a fluorescent light. There's light. There's an electrical discharge that excites up the mercury atoms in that. Or other, like a neon light, the neon or other gases, electric discharge, excite those up. Heat can do it, so that's fireworks. Also here with the flame test, you're using heat. So what happens is the electron absorbs the energy, goes up to a higher energy level, and now as the electron draws back down in the energy level, light's given off. And the combination, you can see there's several different lines, so there'll be a line here going this transition, that transition, so on. Our eyes just average it out. So we're not spectrometers. We're kind of chemical big bags of chemicals that are very good at finding food, mates, and running away from danger. So we assess things really quickly, and so to do that, our eyes just average out any sort of energy that we get in the form of light, and then that average is what we see. So what we're going to go is look for you. The electronic configuration, it just says where the electrons are. And this light, these are sort of fingerprints. So since these energy levels are discrete, the light that each element gives off is a specific wavelength that's unique to each element, kind of like the fingerprints are unique to me. Even identical twins have different fingerprints, so even clones. So using this stuff, be sure to wear your safety glasses as always. And we have the different chemicals here: lithium chloride, sodium chloride, potassium chloride, calcium chloride, and activated charcoal, excuse me. And the idea is you take the paper clips and you make them make a little loop in them and just turn it and then stick it into the modeling clay. This isn't going to get hot. And then you put some of these solution, you dip it in the solution, and use a fresh paper clip each time, because if you contaminate the solutions, you'll contaminate your results, and you'll get different colors on here. So use a new paper clip each time. And then take the candle, light it on fire, and then put the loop in, and this is what I want you to take a picture of, these loops. Take a picture of, take the lithium chloride, put it in the flame, and you'll hopefully see something with that. So then do this again for these other salt solutions, and then record it. So here record the observations you get for all of these. And hopefully you'll see the different colors. And if you don't see anything, put that on there too. I want your results. I don't want made up results. Now these questions here, this is kind of advanced, so I'm just going to go over this one. If you want to take more advanced chemistry classes, you can figure out how to do this. Lithium is 1s2, 2s1, and so the 1s squared are up on the top, 1s2, 2s1. Sodium is 1s2, 2s2, 2p6, 3s1. Calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And carbon is 1s2, 2s2, 2p2. So I hope you can follow my voice in doing this. And the approximate wavelength, so you come here and you look at the color that it gives off, and so depending on what you see, it looks hot pink to me, so I would think hot pink, so reddish color, and then I would come up here and I would look to see what color corresponds to red, and then the color corresponds to red would be, I throw it right in the middle, 700. So if you look at orange, if it's a reddish orange that you see, say it's close to 590 or a 600, whatever. It doesn't matter. This is just a guesstimate. You don't have the chart. You can look in your textbook and see a more exact chart if you really want to hone in on. But you can see here, this just pick something that corresponds to the color shade. And so down here, you get the wavelength, approximate wavelength. And talk about salt. Why does a salt? This is from the quantized energy levels. These give the fingerprints of the atoms. And so we know that's how we know. For instance, the sun is 70% hydrogen and 30% helium and trace everything else. And how do we know that? Has anyone ever been to the sun? No, no one's been to the sun. And how do we know that that hydrogen and helium are there? Because of the light coming from the sun. We look at the light coming from the sun and we can find the fingerprints for hydrogen and helium, and from that we know what the sun is made of. And if you watch some of those shows like CSI, sometimes they do things like this. Do sodium chloride give off similar colors? So I'm not going to tell you the answer to that. Let's see what you think with that. So be careful with this because you do have an open flame, but these chemicals are really, really safe. So these are not dangerous really at all. The only one that has a little bit of a danger to it is the lithium, because don't eat the lithium. Well, actually, don't eat anything in the chem lab, but lithium. But it's lithium chloride. It's probably okay. People that take lithium salts, typically lithium carbonate. That's for what is that stuff called? The manic depressive disorder. People sometimes take that, but be careful, a little careful with the lithium chloride, but it's relatively safe. So please let me know if you have any questions, and happy labbing.